All right, let's get going. So welcome back, everyone. Glad to see you. Glad to see everyone back. Today is an exciting day. As I mentioned yesterday, it is coding day. So we're going to need a couple things here to get started. Number one, as I mentioned before, so adults in the room, I put a Google Doc. And just in case, I'll put it again in the chat. It's a Google Doc, and at the end of that document, it has the sample code of what we're going to be writing today in completion with notes and everything else. So if we get stuck and we have to help troubleshoot a library, which might happen, if you want to have that printed out or if you want to have that displayed for kids, they can always work ahead as we're working to get others caught up and everything else. Okay. So we're going to need a few things today, make sure we have. So we're going to need at least one iPad per group with the Bird Blocks app installed. So that's the app that we're going to be using to code. After that, the other thing that we'll need, where'd my case go? We're going to need our Hummingbird kits. Here, let me grab mine here. So these things here, so you're going to need one of these per group to work on it. We don't need everything out of this kit, so I'll kind of go through real quick, but I'll share my screen and my camera and kind of show you the components that we will need. And then I'll give you a couple minutes to get all that ready and set up and everything else. So let me share my camera. Okay, hopefully that's not lagging too much on your end. Okay, so I'll kind of show you the things that we need, and as I show you them, I'll kind of briefly explain what each one is and what each one does. So out of that kit, most important item that you're going to need to gather up is this guy here. So this is the microbit. I can kind of see the screens here. Raise your hand. Has anyone ever, like at school or anything, programmed or coded the microbits before or used them? Okay, so we're all new to the microbit. That's okay. How about this? Has anyone ever coded before in Scratch? All right, now I'm seeing a couple of hands. That's good. So when we program these microbits, the language that we're using is going to look a lot like Scratch. It's going to be like block-based. So if you used Scratch before, it should look familiar. All right, so real quickly, what is the microbit? So this is essentially, this is a $15 to $20 computer that fits in your pocket. So this was first developed in the United Kingdom, in Great Britain, because they wanted their students to learn how to code. And to this day, it's used as a teaching tool to teach young kids how to code. And in a lot of schools, it's actually required. It's one of the rules. You have to have this on you at all times. It's kind of a rule of the school, but it's a really simple, basic computer that you can program. It has a couple basic features that you can control right on here. So first is it has this bank of LEDs, like the square of lights here. And you can program those lights to like, display words, give messages, shapes, symbols, that sort of thing. It also has 3 buttons, so 2 on the front, an A and B button that you can program to do different things. And then on the back, there's a reset button. So like if you ever need to reset your code or anything like that, you can do it that way. There's also a speaker on here. And then built in these circuits here, there's a couple different types of sensors. built into the microbit, some basic sensors. So like there's something called an accelerometer. So these can detect, you can program to detect like if you shake them or if you tilt them a certain way, or tilt them side by side, front and back, they can actually detect that. And you can actually program these LEDs on the front. You can actually program those to be light sensors too as well. So the great little device, great little computer to program. However, you are limited on the things that you can do just with this microbit. And for the things that we want to do with our pinball game, we need a lot more power, and we need a lot more powerful like sensors and motors and things like that, that just the microbit alone isn't going to be able to accommodate. So we have a second board that we're going to need. So here, if you haven't already, make sure you take a second and make sure you get that microbit ready. You can put that aside. And again, we need one of those per group. Okay. As I mentioned, just the microbit alone is not going to be enough. We're going to need another board to kind of give us more capabilities and more power. And that's where we have this Hummingbird. It's called a Hummingbird bit. Okay. So this board works with the microbit, and it just gives it more power and more options. So how this works, and if you want to get your microbit, go and take that, and it snaps into the Hummingbird bit like that. If you want to do that now, you can have that ready to go. Okay. As you're doing that, as you're snapping the microbit into the Hummingbird bit, just a couple things to point out, just some things that we can do with this Hummingbird bit. Okay, first, and these are all labeled, so you're going to see here on the right side, it says servos. Okay, so servo is just another name for a motor. Okay, so over here, and we have 4 ports for motors, and they're numbered 1, 2, 3, and 4. Okay, so when we program today and when we hook things up, we will be connecting at least one servo motor in port 1 today, which we'll get to that in a minute. At the top of the Hummingbird bit, these are the ports for what are called LEDs. So an LED is just a light, different than the lights a little bit different than the lights on the microbit. These ones are a little bit more powerful. We have tricolor, 2 ports for tricolor LEDs, which you do have an option to use, but for today, we're going to be using kind of like the basic LEDs, these yellow ports here. And we're going to be using port 1 and port 2 for those. Okay. All right. The last thing to point out on this board is down here, these blue ports down below, and you can see it. They're labeled. These are where our sensors go. Okay. And so we're going to be using 2 different types of sensors today. One to detect if we score a point, and then we're going to use the other sensor, a light sensor, to detect if like a ball drop, if a marble falls past or paddles. Okay, and so that's going to be these ports here, and we're going to be using ports 1 and 2 here today. Okay, and there's 3 ports for sensors there. Okay, so at this point, right, you should have the microbit snapped into place into the Hummingbird bit. Next, we need to get a very, very important piece of equipment, right? Because none of this, we can't do anything if we don't have electricity, right? So what you're going to need, the kits come with a a battery pack that takes 4 AA batteries. Okay. So here's where we might need to pause because you might need to get that ready. But you'll need 4 AA batteries in here. And then once you get your batteries and get them in the battery pack, go ahead. That plugs in to, there's a barrel port in the bottom right of the Hummingbird kit, and that's where that plugs in. I'm not going to use the battery pack. I actually have an AC power adapter, 5-volt power adapter, that can plug in. So, it's possible you might have a power adapter like this one around the library, which is good to use. It saves batteries if you have one, but if not, the battery pack will work. Okay, so let me plug that in. And here in a second here, you're going to see if everything's working correctly and you have power. Yep, you can see it here on the screen. So this is what you should see. Once you have those 3 things plugged in, you have the microbit plugged in to the Hummingbird bit, and then you have it plugged into the power supply to the battery pack. What you're going to see, it's going to flash kind of a message across the screen, across the LEDs of the microbit. So it's going to be like 3 letters, then like the number sign, and then like a number that flashes. And that's what we want. So that means it's ready to pair with the iPad. Okay. So let's take a minute or two. Let's get all that hooked up. Let's get power running to your microbit. Make sure that we see that message scrolling across your microbit screen. And then if you could just give me a shout, give me a thumbs up, whatever, let me know that we're good to go here. Okay, I think Phoenixville. I think I got a thumbs up from Phoenixville. Okay, we got a thumbs up from Newcastle. At Glen, how are you guys doing? Oh, thumbs up from Macklin. Royersford, there's a lot more people at Royersford. Oh, we got a thumbs up though. Awesome, awesome. That's what I like to see. Thanks, guys. Oh, yep, we got a thumbs up from Cheltenham. Thank you, guys. All right. A lot smoother than the first group. We ran into an issue right off the bat. I should probably mention this too, just to make us aware and to kind of put us in the right mindset. So, part of programming, a big part of programming is something called debugging. And all debugging means is that you're fixing things that don't work. So keep that in mind. Like as we do this, we're going to do something, we're going to try something, and it's not going to work, and then we have to go back and we have to do a process called debugging, where we have to check certain things and try to fix the problem. Okay, so part of coding, in order to be a successful programmer, is you have to be a patient, and you have to be able to work through problems that come up, that arise. Okay, all right. Before we actually start coding, though, we're almost there. Let's get a couple more pieces of equipment ready to go. Okay. And, we're not going to plug them in yet, but I just want you to have them handy and ready to go. So the first thing to get out of your kit is go to your motors. Now there's two different types of servo motors, and the kind that we're going to use today, putting up on the screen, is called a rotation servo. Okay. And it has the symbol on it, like the circle symbol on it. Okay. So just have that ready, get that out. And I mentioned too, I'll just point this out, because you could incorporate this in your game if you wanted to, but there's a second type of servo that you're going to see. It's called a position servo. We're not going to use it today. You're welcome to use it in your game though, but I'm going to real quickly, I'll explain the difference between these two types of motors or servos. So keep in mind, a servo is just a type of motor, right? So the rotation servo, just as like the name and the picture suggests, right? This moves in 360 degrees. So it moves in a complete circle all the way around, and it can move clockwise or it can move counterclockwise. So it can move in either direction. This kind of motor is good, like if you're making, like I always think, like if you're going to make like a car or a self-driving car and you need to power the wheels, right? Well, with wheels, you want that to rotate 360 degrees. You might want it to go forward, or you might want it to back up and go in reverse. Okay, so like these rotation servos are especially helpful for wheels. We're going to use it. You probably saw in my pinball game, I had the star at the top that kind of hit the ball in random directions when you drop the ball in. So that's how we're going to use it and program it today. The other servo, and again, like I'm not going to show how to program this today, but you are welcome to use this in your game. It's the position servo. So this is a little different than the rotation servo. The position servo does not move in 360 degrees. It moves from 0 to 180 and back. So it moves in like a semicircle, just like the picture kind of shows on there. So I always think like, position servo would be good for something like a crank, or if you're making like an excavator or a crane, something like that, you would want the position servo that moves 180 degrees. So we're not going to use the position servo today, but you could certainly incorporate that in your game if you wanted to. Okay, so we have our rotation servo. Just have that, put that aside. We're going to need 2 LEDs. Okay, and the LEDs, you can choose any color that you want. I'm going with yellow and green. Today, I'm not going to show you the tricolor ones, but like we do have more complicated tricolor LEDs that can turn like different multiple colors and stuff like that. I'm going to use kind of the simple LEDs here. for us to get started. But again, you're going to need 2 of these simple LEDs. I chose green and yellow. I think there's also a red one if you wanted to use the red one. But let's gather those up. And you can put those aside, keep them handy. Okay, now let's get out the sensors that we're going to need. We're going to be using 2 sensors today. All right, so the first sensor, I say it's the first sensor, but this one, we're actually going to plug this into port 2. So this is called a distance sensor. So it looks like this, kind of looks like it has eyes. But what a distance sensor, it's going to detect movement and objects that happen within a certain range of it. And we get to tell it what that range is. But you probably have encountered these before, like maybe on your house, you might have like outside lights that turn on, like when you walk past a certain sensor. That's a distance sensor that's being used. Or maybe like at school or in the library, you might have like lights that turn off, and then when you walk into a room, the lights automatically turn on. Again, that's using a distance sensor. It's detecting movement within a certain range. So have that distance sensor handy. We're going to be using this to detect the marble in order to score points. So that's what we'll be using this for today. And again, it's going to be plugged into port 2 here eventually. So we'll just put that aside for now, have it handy. All right, the last thing, and this is another sensor to get out of your kit and have handy. This is our light sensor. Okay, and actually says light sensor right on it as well. So what this does is, just as the name implies, it's going to detect the presence of light, or it can detect like the absence of light. And we're going to be using this for our ball drop to detect what I call ball drop. So basically when the marble falls past the paddles, right, it's going to get caught. You're going to have a way to catch that marble, and then this will get covered up by the marble, that sensor, okay, which is going to block the light from reaching it. And basically we're going to program it that when the light is blocked, it's going to register a ball drop, and that's how we're going to use that. And this, we're going to plug this into port 1 here eventually. Okay. So can I get a quick thumbs up? Are we good? Did we find all those components that we're going to need today? All right, good. I'm seeing some thumbs up. All right, it looks like I think we're ready to start coding at this point. Okay, so I'm going to leave my camera and I'm going to launch the Bird Blocks app. Let me disconnect my device. Okay. So I'll give you like 30 seconds here to find that app. It's called Bird Blocks, BirdBlox is the name of it. All right, cool. So first thing we're going to do, and I'm going to give you a couple of minutes, we have to connect. We use this app to kind of connect the iPad to the microbit, and it connects via Bluetooth. So what we need to do first of all is we need to make sure that on our iPads, Bluetooth is turned on. And so here's how you can quickly check whether Bluetooth is turned on or not. In the top right-hand corner, if you just swipe down with your finger from the top, you should get this menu. This is called the Control Center. And then there's a couple, like 4 icons here. We have our AirDrop, Wi-Fi, and then you'll see Bluetooth right there. So let's just take a couple seconds. Everyone, if you can go into that control panel, again, you got to swipe down from the top right and just make sure Bluetooth is turned on. And then once again, if I can get a quick thumbs up. All right, looks like we're good to go. That was pretty simple. Okay, now that we know Bluetooth is on, let's connect the iPad to our microbits. So here's how it's done. Top left-hand corner, you're going to see the Hummingbird icon. And then you probably see like a black dot right there. Okay, that means we're not connected. So what we need to do is we need to tap on that icon. Then we need to select connect device. Okay, you might get like a message saying, searching for devices, but then you should have some devices come up. Now, pause for a minute. Don't select anything yet. Okay, because you have friends sitting next to you that are also connecting. And you might be detecting their microbit. Okay, so what we need to make sure of is we need to make sure that you're connecting to the correct microbit. Okay, so if you look at the microbit, right, that message that it's flashing, right, those first 3 letters that flashes on the thing, that's what you're looking for, right? So the first 3 letters on my microbit are IMS, which apparently stands for Interesting Moonstone Stegosaurus, right? So make sure that you connect and that you select the right microbit. You don't want to connect to someone else's microbit across the room, okay? So I'm just going to select that. It'll take a couple seconds. I'll hear a ding, and then that light will turn green, and that's how I know I'm connected. If you accidentally connect to your neighbor's microbit, you can always go back there and you can disconnect the device and try again. Okay, so I'll give you a minute or 2 to get connected, and then as always, if you can give me a quick thumbs up. Thanks, Cheltenham. At Glenn, how are you guys doing? Okay, thank you. Newcastle. Good. Looks like we got some thumbs up.
Yeah, we're doing good. Me and Sophia are figuring it out because like we never used it before.
Yeah, it's going to take some getting used to.
Oh.
Phoenixville, how you doing? I got a thumbs up and a dance. You're doing really good. Okay, they're bringing it. All right, so now let's get going now. So that's, guys, pat yourselves on the back. That's like the toughest part of today is just getting things connected and getting them up and running. So like you guys did an awesome job working through that. Okay, so really great job. We had a group this morning that really struggled to get connected. So that's great. All right, so let's get started here. What I want us to do, top left-hand corner, okay, you'll see it'll look like a paper icon. I'm going to click on that. And this is where we can create our programs, right? So I'm going to go ahead, I'm going to create a new program. You can see a couple of my programs I didn't give good names to. It's really important to name things in coding and to give good names. So what I'm going to do is I'm going to name mine. I'll name mine like pinball machine. Okay, but feel free to name your program. You can like if you came up with a title of your game, you can name it after the title, or you can name it pinball machine, whatever works for you. Okay. All right, so moving on. So now we have our program. Mine's named Pinball Machine up here. I'm connected. I'm ready to go. So a couple things to point out here. And again, if you've ever used Scratch, this is going to look very similarly. There's a list of like 4 devices with blocks under the Robots tab. The device that we have is the Hummingbird kit. So make sure you have the Hummingbird bit. Expanded. These are the blocks of code that we will need and we will be using are in here. Okay. After that, we have some other options and like another menu up here. And we'll be bouncing around in like all these menus or most of these menus as we work. Okay. And they're color coded, which is nice. Similar to if you ever used Scratch before. Okay, so let's start off. Let's bring in our first block of code. So we're going to go to control, which is the yellow tab right there. And then what I want us all to do is our very first block of code is going to be when the green flag is tapped. So we're going to grab that one and we're going to drag that onto the board. Okay, like that. Okay, so what that block of code does, that is going to start the program, right? Or that's going to start the game. So whenever we want to play the game, we have to go into here and we're going to have to hit that green flag in order to start. Okay. Next thing I'm going to do, I'm going to pause for a minute from coding and we're going to do a little brainstorming together. Okay, so let me bring up 2 questions for you I want you to discuss with your partner, and I'll give you 3 minutes to discuss these 2 questions, right? So, before you dive into coding, one thing that you want to do and what any professional programmer will tell you to do is always plan out what you want to program before you start programming. Okay, so 2 questions to think of. The first question, right? What information will we need to keep track of? So as we're playing the game, the microbit is going to have to keep track of information. What information is it going to have to keep track of for us? So that's the first question. Second question, what functions or tasks need to be completed while playing the game? So what is that microbit going to have to do? Or what things will have to occur throughout the game? So again, this is just a little bit of brainstorming for our programming. So I'm going to give you 3 minutes, talk with your partner, write down some answers, and then I want to hear some share out at the end of 3 minutes. I'm going to start that on my phone. Go. All right, one more minute left to brainstorm. Okay, timer is up. So let's take the first question that we had to think about. So what information are we going to need to keep track of as we play the game?
All right. One of our kids says points.
Okay, excellent. So we need to keep track of the score, right? What's the second thing that we might need to keep track of?
They're saying lives too.
Oh, lives. Okay. Yeah, so that's a good way to name that too. So like how many lives? I'm going to call that ball drops, right? How many marbles, how many times the marble gets past the paddles, right? So you could call that lives, you could call that ball drops. But yeah, either one of those will work. And those are really the two big pieces of information that we're going to have to, we need the microbit to keep track of, right? Okay, now who can tell us, second question, right? What kind of tasks are going to need to be done by the microbit?
I know this may not be like part of like the second question, but like I'm gonna have to like restart mine because like my original idea is to use like a cardboard box, but like I want mine at like an angle, but like it wouldn't really work. So I'm gonna have to like restart.
Okay. Was the incline not steep enough?
No, no, it wasn't
Okay.
like I was gonna have to use like support beams, but like I know it'd like kind of fall down because like the weight of the cardboard box would probably like make it like crush it a little.
Yeah.
So so I'm gonna have to like restart.
Yeah, that's okay. That's all part of this, right? We might have to go back and fix things as we work. Yeah. All right. So how about question 2, right? What other tasks are we going to need to complete?
I'm gonna mute it. The question's up there. This is number 2. To get the emotion.
To reach their goal. So the functions or their task is to reach their goal.
Yeah, I think I heard it there. So, right, the goal is to score points, right? So we're going to need a way to detect, and we're going to score points by sending the marble towards an object, right? So that's one task. We're going to need a way to detect points and also to record those points as well, right? Not only points, but speaking about like lives or ball drops, we're going to need a way for us to detect when a marble gets past the flippers, right? And then we're going to need a way to record that. How many lives do we have left to play, right? So when I show you how to make my sample program here, I'm going to say that we have 3 lives, 3 ball drops possible, but you can change that. You can make it more difficult. You can say, no, you only get 2 lives, only 2 ball drops. Or you can make it a little bit easier and you can say, no, maybe 4 or 5. That's going to be up to you, but usually the standard is 3. And that's what I'm going to go with. Okay, so now that we've done a little bit of brainstorming, and really like this is a big question here, that first one, kind of thinking about what information we're going to have to track as we code this, because that is going to be the first thing that we do in our coding. Okay, so I have the Bird Blocks app up. What we need to do is way to think about this is we need to make containers to hold that information that we need to store. So you can think about this kind of like, I don't know if you can see me, but think of that. Think of this like a glass or a cup, but rather than water, okay, it's going to hold, one's going to hold a score, and one's going to hold the number of balls that have dropped past the flippers. Okay, so where we need to go to make those is we need to go into variables, right? And all a variable is, it's a container that holds information. That's what a variable is. Okay, and what I'm going to do is we actually have to make those blocks. We have to create those variables, right? So I'm going to go ahead and create a variable. And this first variable, we're going to have that hold our score, right? So because it's holding our score, I'm going to name it score. And then press OK. Okay, so that's our first variable. Again, I'll say it again, a variable is just a container that holds information. Okay, in this case, our first one is holding the score. All right, let's create a second variable. Go ahead, create that. This one, we need to track how many times the ball drops, or in other words, falls past the flippers. So I'm going to name this one. If you want to name it something different, you can, but I'm going to name it ball drops. And again, with my game, I'm going to only allow 3 ball drops. And at the third one, it's game over. Okay. All right. So right off the bat, we're going to use these. We're going to use these 2 variables. So you can see they're up there. And then right below, there's this block to set, right? Right now, it's showing the last one, ball drops. But if you go to the drop down, you can switch that to score like that. So I'm going to use this set block. And I'm going to move that into position first. I'm going to attach that to the when green flag is tapped. And make sure that it says score. And I'm going to set that to 0, right? So this means when we start the game, when we click on that green flag, our score gets set to 0. Okay, and that's going to be pretty important because we don't want to like take the score from the previous player's game and start adding on to that. That wouldn't be very fair, right? So we want every time that we start a new game, our score starts at 0. Okay. Next, I'm going to drag this block again back in, but this time, rather than score, I'm going to choose ball drops. Okay, and that I'm going to set to 0, just like I did with score. So this means every time that we start the game, our ball drops get set to 0, right? Which is important because we get 3 of them. And on the third one, it's game over. So we want to make sure that we start the game with a clean slate and that we're at 0 ball drops. Okay. All right. So I'm going to call this like our intro code, right? Our getting started code right here. So there's one more block I'm going to use in our getting started code. Go to robots up here. And then if you scroll down, you're going to see this block that says bit print, and then you could type a little message in there. So by default, it says hello. But have like an intro message. So I can say like, ready? Just like a little message to like welcome the player and get started. Okay, so take a couple seconds, put that block in, type in your welcome message, and you can leave it hello if you wanted to. All right, after you type in that message, so here's what we're going to do. We're going to test it. So like as we add code, so we're going to be constantly adding code blocks and then constantly testing and make sure everything works the way that we want it to work, right? So after you add that, I'm going to press that green flag, and then I'm going to look at my microbit, and printing across the screen, I have my message. So like, I can't show you because then it wouldn't work, but like you should see your message printing across the microbit LEDs when you hit that green check mark. And that's our first block of code that we just wrote. So give me a thumbs up if you were able to do that successfully. All right, awesome. You guys are doing great. Okay. Now, we still have a little bit of intro code. So like, this is what's going to happen every time we start. Let's go back to control, the yellow code blocks. Okay. And then I want you to find this block here that says repeat until. Okay. So this block here is going to be really important, this repeat until block, because basically everything that happens in this block is basically going to be what is going to be the things that need to occur while we are playing the game. Okay. And I use the repeat until because I'm going to say basically repeat until there are 3 ball drops. And once there's 3 ball drops, it's going to be game over. The game's going to end. But until there's 3 ball drops, we're going to execute all the code that's in this block. So this block here is going to contain a lot of code and a lot of blocks. Okay. So let's finish setting up this block. You can see we have like a hole here. So we need to fill that in. So repeat until, and I'm going to go to the green operators up here. And I'm going to find this block. It says like 0 equals 0. I'm going to take that and I'm going to drag that into position there. So it should look like that. Now, this doesn't make much sense right now, right? It says repeat until 0 equals 0. Okay, but we're going to make it make sense here in a second. So once we have that, we're going to go back up to variables, the red blocks. And this time I'm going to see the oval for my variable for ball drops. I'm going to grab that one, and that goes in the first circle right there. Okay, so I'm going to say repeat until ball drops equal. Here's where you get to decide how difficult do you want this game to be, right? Do you want to do the standard number of ball drops that are allowed in pinball, which is 3? That's what I'm going with, okay? But you can make it a little bit more difficult. You could choose 1 or 2, okay? That would make it a more difficult game. Or you can make it a little easier and go with like 4 or 5. Okay. All right, you guys with me so far? Quick thumbs up. Ackland, you good? All right. All right, so now let's start building out inside this repeat until. So this is all the things that are going to occur once we start the game, once we have the game underway. And notice I didn't, the setting the score to 0 and setting the ball drops to 0, I needed that outside of this, right? Because if I put that inside while we play, it's going to be a never-ending game. Like our score and our ball drops are going to keep on resetting to 0. So that's why I have it outside the repeat until block. Okay, so that's really important. Okay, all right, so let's get going. Some things that we want to happen while we are playing the game. I'm going to go back to the robots, kind of like the teal blocks, and find that bit print block again. And I'm going to drag that into the repeat until space there. Okay. Now, I don't want to give a greeting again. I already gave a greeting up here, right? So what I want to display once we are playing the game, okay, we need to tell the user, we need to tell the player how many points that they have, right? So what I'm going to do once I have this block in, I'm going to go up to variables. I'm going to get my oval that says score, my variable that says score, and that I'm going to drag into place there. Okay. So now, again, once you do that, okay, so again, we're making small changes. Every time we make a change, we test, right? Make sure it works right. So I'm going to go up to the green flag, press it. I'm going to look at my microbit. I see ready come up, and then flashing on the screen over and over again, you should have 0, which is your score right now. Okay. All right, no one's screaming, so I think that should have worked okay. So I'm going to stop the code right now. Let's keep going. All right, so the next thing that I want to happen with my pinball game, right, I had that servo rotating randomly at the top that kind of kicked the marble one direction or the other. Okay, so I think the next thing, after we display the score, let's start rotating that servo randomly. Okay, so here's what we're going to do. I'm going to go back to my camera. Okay, find that rotation servo. We need to plug that in. Okay, but before you plug it in, okay, so I'm going to plug this in. Remember, the servos are here on the right-hand side. We have 4 ports and they're numbered. Okay, it's very important which number we put this in, and you got to keep track of where you're plugging things into. Okay, so I'm going to use port 1, and I'm going to remember that I plug the servo into port 1. Now, above the ports, I don't know if you can see here, but there's a minus sign, a plus sign, and an S above the ports. What you need to do before you plug this in, you need to line up the wires correctly with those symbols. So here's how this works, and this is kind of universal. The black wire, that is your negative, okay? So that needs to be lined up with the minus sign. Your red wire is always going to be positive, okay? So that needs to be lined up with the plus sign. And then the wire that could be, it could be any color. In this case, it's white. That's your signal or your S. So that needs to be lined up with S. Okay. So if you don't plug this in correctly, it's not going to work. Okay. So again, general rule for the servos, line up the black wire with the minus sign. And then you can plug it into port, let's use port 1. Okay. So last thing, I should have had you get this out when you got the servo out. So in your kit, there's this baggie of these plastic things. These are called servo horns. Okay. And what these do is and there's different shapes. Some are like star shaped, circle, whatever, but these snap onto the top of the servo here, right there. So I'm going to take kind of the star one. You can use like the circle or the star, and I'm just going to snap that on top of the servo like that. Okay. Once we have our servo plugged in, let's go back to our code. Okay, so we're ready to code that servo. We need to go back to the teal robots blocks. And over here, you're going to see one that says bit rotation servo. Okay, so there's two servo blocks. One is for the position servo, one's for the rotation servo. So what we just plugged in was the rotation servo. I'm going to drag that block over like that. Okay, while that's in there, a couple things to point out here. So you can see it says bit, here, let me zoom in, but it says bit rotation servo, and then there's a number. Well, if I go to this menu here, right now it's 1, you can see here's my ports that I could plug servos in. Remember, there are 4 ports. So this is where it becomes very important. You got to know which port you're plugging your different components into. So I definitely plugged that into port 1. Okay. Now that's at like 0%. So if you remember from my game, what we need this servo to do, we just need it to like rotate randomly in like random directions, left and right, at random angles, random speeds. So there's a way that we can kind of make this turn randomly. What we need to do is go to the green blocks that say operators at the top. And then we get this option to pick random. It says pick random 1 to 10. I'm going to drag that in and replace that with that. All right. Here's the thing. I'm not going to leave that 1 to 10 though, because that's not a very big range of rotation. So I'm going to replace 1. I'm going to press that. So you can see there's like a plus and negative. I'm going to make that negative 360. So that would be like turning counterclockwise, negative 360. Then I'm going to replace 10 with just positive 360. So it looks like that. And that would be turning clockwise. So basically what we're telling it to do is like, hey, rotate randomly counterclockwise and then clockwise, and just do that randomly. And after you do that, there's one more thing we have to do for that motor. Because if you play it now, you're going to see, if you hit the green flag right now, you're going to see it's not going to turn. It's going to get like confused. So what we need to do is we need to go back into our yellow blocks, go back to control, and we need to put in a wait block. I'm going to leave that at 1 second. You can experiment. You can put 2 or 3 seconds or whatever. But I'm going to leave that at 1 second. Okay. Once you have that code complete, okay, remember what we do, right? We test. So once you have it complete, tap on the green flag. Okay, it's going to say ready. And it's displaying the score. And for me, it's rotating that servo randomly. It's going, sometimes it's going fast, sometimes it's going slow, sometimes it's going counterclockwise, sometimes it's going clockwise. Okay, I'm going to stop. Go ahead and work on that. When, give me, as usual, give me a thumbs up if you were able to get your servo randomly spinning in different directions and at different speeds. So at Glenn got it. Yeah, good job, guys. Newcastle, how are you guys doing? Oh, Newcastle got it. Thanks. Cheltenham, how are you guys doing?
We're still figuring stuff out.
Okay.
We're good over at Royersford.
Awesome.
So the kids might need a wiggle break in a little bit.
Okay. Well, why don't we do that now? Why don't we take, this would be a good pausing point, I think. So why don't we take, and there's some teams that need to troubleshoot a little bit. So I'll be here. We'll take five minutes.
Sounds good.
And if you need, I'll leave the code up on the screen here if you need it, and then I'll be on too if you need help.
All right, awesome. Thank you.
Yep. Okay, let's keep going. Like, hopefully gave us a nice break. Okay, so what we're going to do next, we're actually going to put the code aside for the moment. And I think what we'll do is we'll spend the rest of the day hooking up our remaining components. Okay. So what we're going to do, what we're going to hook up first, okay, and these ones are, I'll warn you, these next things are a little bit more tricky than the servo. Plugging in the servo was easy. Okay, these ones get a little bit more tricky. So what we're going to do is we're going to start with this distance sensor. So what you'll need is you'll need that distance sensor we got out. And then you're going to need one of the LEDs to go with it. And basically the thought here is that these two are going to go together. So basically the distance sensor is going to detect when a ball comes near it, and that's going to assign a point. And when we get a point, we have to let the player know. And one of the ways that we're going to let the player know is that we're going to, a light's going to light up and blink and flash. Okay. So these two are going to work together, this LED and the distance sensor here. Okay. So what we're going to do is we're going to plug in the distance sensor first. Okay, so again, this is trickier than the servo. So there's 3 wires in 3 different colors. So there's black, red, and in this case, yellow. Okay, so if you remember my explanation from the servo, black is always negative. If there's red, it's always going to be positive. And then like an other color like white or yellow, that's going to be the signal wire, okay, or the S. Okay, now we're going to put these not in port 1, but instead we're going to put these ones in port 2. Okay, and you can see above each port or above each entry, there's our negative, our positive, and our S. Okay, now especially for younger kids, this can be a little tricky. Okay, so watch closely how you have to do this. So I'm going to put in the negative first, right? So I'm in port 2. I have the negative sign, the minus sign. So that goes in that hole right there. It's closed right now, so I need to open it. And to open it, I need to press that button that's above it. Okay, that could be tricky to do just with your fingers. So these kits come with these tools here, these like orange tools that can help you press these buttons. Okay, but I anticipate like some of us, like they even like cause me fits sometimes. So I anticipate that this might take us a little bit of time to get these plugged in, to get these wires plugged in. Okay, because you need kind of like some fine motor skills. Okay, so I plugged in port 2, I plugged in my negative, the black wire, and I made sure that lines up with the minus sign. Okay, and you might want to test, like give it, don't pull on it too hard, but just give it a light tug, make sure it's in there securely. Okay. All right, after the negative, after the black wire, I'm going to do the positive or the red wire, which goes in next to it. Okay, so now that's in, and again, just a light tug, make sure it's in there securely. And then I'm going to do the signal, the S. Okay. And in the end, again, that's my distance sensor, and I'm using port 2 for that. Okay, and it should go right to left. It should be black, red, yellow. Okay, I'm going to emphasize that order is very important, because if you have it out of order, it's not going to work. Okay, after I have that plugged in, I said there's an LED that goes to it. So basically, when that distance sensor gets triggered, it's going to add a point to score, and it's going to let the player know by one of the ways that it's going to let the player know is it's going to have a blinking light. So I'm just using the yellow LED for that. And that too, just so I can, this is helpful for me, like just to have them in the same port, just knowing like, okay, I did my distance sensor in port 2, the light that's going to work with it, I'm also going to put that in port 2, just so I know like, hey, those two things are working together. Okay, and that just helps me be a little less confused. Okay, so with the LED, again, black is always negative, or you line it up with the minus sign. Okay. And then in this case, the positive is the yellow. Like I'm using the yellow LED, so the positive is the yellow one. And there's no S cord, because these are a little bit more simplistic than the sensors and the servos. Okay, so that's what I have so far. Okay, so I'm using port 2 for both of these. I have my distance sensor in port 2, again, right to left, black, red, and yellow. In port 2 for the LEDs, I have my yellow LED, and I have black and yellow lined up. Okay. All right, after that, we're going to plug in everything else. So, and again, this will be the last thing that we tackled today, and then we'll get to the rest of the coding tomorrow. But we'll just get everything hooked up today, and then finish the code tomorrow. So after that, once I have those two things hooked up, I'm going to hook up my light sensor, right? And remember, the light sensor, I'm going to use that to detect drop balls. So whenever a marble gets past the flippers, it's going to block this light sensor. Okay. So this sensor, I'm going to put this in port 1. Okay, so this is going in port 1. And we plug it in the same way that I plugged in the distance sensor. So I'm going to take the black wire first, make sure that's lined up with the minus sign, make sure that's negative. I'm going to take my red wire. I'm going to line that one up with my positive, or my plus sign. Then I'm going to take my yellow wire, and I'm going to line that one up with S, with the signal. Okay. So far my board should look like this. Okay, one more LED to plug in. Basically how this is going to work. This LED in mind, this green LED is going to shine a light on the light sensor. Okay, and then the marble, when the marble drops, when the ball drops, it's going to interfere with that. It's going to get in the way of that light beam and block the light from the LED from reaching the light sensor. Okay, so this LED is going to go with this light sensor. Okay, so I put this light sensor in port 1. That means, just to help keep myself organized, I'm going to put this LED in the port 1 in the LED bank. Okay, so just like I did with the yellow LED, I'm going to go to the yellow ports up here. I'm going to take my black wire first. Make sure that's lined up with negative or the minus sign. Okay, so that's in. Then I'm going to take my green wire and make sure that is lined up to positive. Okay. So this is what my board should look like. Okay, so the adults, if this sounds okay with you, so maybe we'll give them, because it might take a little bit of time to get everything plugged in, especially if you have younger ones with you. They might need a little bit of help with it. So why don't we, that'll be the last thing that we do today, or the last thing that I showed today. We'll be getting everything plugged in on the board, and I'll leave this up. I'll leave my camera up so that you can see where everything gets plugged into. Tomorrow we'll finish the code for this. That shouldn't take too long. However, I did give you the code that we're going to be creating. So if you do have kids that are already plugged in and they're ready for to code the rest of it, you can certainly give them that code, and they can start working on that too as well. Or if they want to go back and 3D design some more or work on their board, they can also do that too. But I think we went through a lot, so we'll give them a break right now. And I'll stay on the line for like another 10 minutes in case if you need help or if you have any questions.